A plano-convex lens of refractive index 1.5 and radius of curvature 30 cm is silvered at the curved surface. Now this lens has been used to form the image of an object. At what distance from this length an object be placed in order to have a real image of the size of the object, right? So this is basically a plano-convex lens and it is silvered from the curved side, right? Now if we place an object, so we have to get the object real image and it should be the same size. That means it should be kept at C, center of curvature, and what is basically the distance U? U is for C is twice of F, where F is the focal length of the system, right? The system. So if we see incident rays which are going in, what is happening to them? They are first getting refracted from the lens, then reflected from the mirror, and then again refracted, right? So that means two refractions are there and one reflection. So if I talk about the complete focal length of the system, that will be 2 upon FL plus 1 upon FM, where FL is the focal length of the lens and FM is the focal length of the mirror. From lens maker's formula we can calculate the value of FL, which will be mu minus 1 into 1 upon R1 minus 1 upon R2, where R1 is the radius of this surface and R2 is the radius of the curved surface. So that means R1 will be infinity because it is plano-convex lens, and R2 is given as 30 centimeter. R2 will be minus 30. See, different students might be having different sign convention. They might be using different sign convention. But over here at Zion Tutorials, what we use is that all the distances are measured from the pole, right? And if we go in the opposite direction to the incident ray, we take those distances as negative. For example, the radius will be somewhere here, it will be this distance. So if I go from pole, I will be going in an opposite direction as compared to the incident ray, right? So that means I will take this radius as negative, right? So that means 1 upon FL will be equal to 0.5, which is 1.5 minus 1, 0.5, 1 upon infinity minus of 1 upon minus 30, right? So this will be equal to what? 1 upon 60. And what about 1 upon FM? FM will be what? R by 2, because this is the radius of the mirror is 30. So the focus will be at this distance, R by 2 distance, 1 upon 30 by 2, which will be equal to 1 upon 15, right? Now let us put this in this formula. So 1 upon F will be equal to 2 upon 60 plus 1 upon 15. This will eventually come out to be 1 upon 10, right? Now where this should be placed, it should be placed at 2F. That means it should be 2 into 10. That should be equal to 20 centimeter. That means option C is correct.